Here are the things you need to memorize from Unit 2. This chart shows the graphical relationship between the original function f, the derivative f prime, and the second derivative f double prime. It's a slightly more detailed version of this chart that I've been trying to get you to memorize since the beginning of Unit 2. So, if you have not memorized this information yet, please pause the video right now and commit this to memory. My recommendation is that you should draw this little chart in the margin of your test before you begin. If f prime is positive, f is increasing. If f prime is negative, then f is decreasing. So these first two facts are right off of that chart. So it stands to reason that if f prime is 0, then f is neither increasing nor decreasing, meaning that f is a horizontal tangent line. There are three different things in function f that could cause f prime to be undefined. It could be a discontinuity, like a hole, a jump, or an asymptote. It could be a cusp, meaning some type of a sharp corner, or a vertical tangent line. Also, if f prime is not defined at A, then f double prime is not defined either. Switching over to the top part of this chart, we know that if f double prime is positive, f prime is increasing, and f is concave up. If f double prime is negative, f prime is decreasing, and f is concave down. I'm basically going to copy the same information into this new, more detailed chart. So here again, if f double prime is positive, f prime is increasing, and f is concave up. If f double prime is negative, f prime is decreasing, and f is concave down. If f double prime is 0, then f prime is neither increasing nor decreasing. What's another way of saying that? If a graph is neither increasing nor decreasing, it must be horizontal. And since we're talking about a specific value of x, we should say horizontal tangent line. And what about function f? If the graph is neither concave up nor concave down, it must be linear. And if f double prime is not defined, that means the graph of f prime must have either had a discontinuity, or a cusp, or a vertical tangent. Here are the basic derivative rules that we have learned in this unit. Starting with the power rule, the derivative of this, the n is going to come down to the front and give us an times x to the n minus 1 power. And then there's the product rule, where we take the derivative of the first factor, so that'll be f prime, but then we multiply by the second factor unchanged, and then we add, but the second time through, we take the derivative of the second factor while leaving the first factor alone. So I have f times g prime. So there's your product rule. For the chain rule, first you take the derivative of the outer function, and for a minute there you leave the inner function alone, but then you multiply by the derivative of the inner function. So there's the chain rule. And then there's the quotient rule. This is where you try not to disturb the person sitting next to you while you mutter the quotient rule poem to yourself. Low D high, less high D low. Draw the line, and down below, the bottom squared will go. So let's see what that means. Low D high. Low is G, and then D high, the derivative of the top part, so that would be f prime. Less means subtraction. And then high, D low. High is the top function. And then D low, the derivative of the bottom function. Draw the line, and down below, the bottom squared will go. The quotient rule. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So everything I just went over, you just simply have to memorize. And this is going to come up over and over again for the rest of AP Calculus. So do yourself a favor, memorize this thoroughly now. This list is only going to get longer, unfortunately. There are two versions of the limit definition of the derivative that you should have memorized. There's the alternate definition of the derivative, which this is the one that looks like an old school y minus y over x minus x, like slope. And it goes like this: f of x minus f of c over x minus c. So you can see the y minus y over x minus x. As I switch over to the other version, notice that both versions have f of c right here. That helps me remember them. So for this next one, this is the one that involves h. So we have the limit as h approaches 0. And so our y minus y is going to be f at c plus h minus f at c. Remember, I told you both of them have f at c right here. But this one simply has h in the denominator. So memorize both of these.